So our final descriptive statistic is the standard deviation. And this gives you more information about your distribution of your data around the mean. So you need to have a normal distribution where the mean is a central tendency that you know you can use for those data. So we're going to focus on the building age at this point for this example. And I've collected all of those central tendency data right here so we can look at them. Now, what you're looking at with a standard deviation is essentially how much variation do you have in your data, and how closely does any given value kind of collect towards that mean value in the center. We don't have to worry too much about variation and a technical definition of that here, but we know that a smaller standard deviation means we have lower variation in our data. This is just another one of those descriptive statistics that we can use to understand how confident we are about the data, what the characteristics of those data are, and how we want to use those in our analyses. I've created a column here where we're going to be able to calculate our standard deviation. And in this case, the math underlying standard deviation is a little more complex than something like the average. And honestly, for your purposes right now, you don't need to worry about what the math is. You just need to understand the concept. So we're going to drop the formula in here from Excel. I start typing ST, like I'm going to start typing standard deviation. And here it comes. And we're going to select the standard deviation, and it's kind of snuck over on me here because we're working to the right a bit more, of the age of our building. And we're going to drop that in here. As an aside, you may have noticed as we were going along that I kept getting this little error and I was trying to ignore it and not let it get in the way. I'm going to tell Excel to ignore this error. It's giving me that because I'm selecting an entire column and there are empty values eventually down in that column if I scroll down here, and it's just trying to alert me to that. You can avoid that error by just selecting the column, the rows in here that you want to use. It's sort of 6 of one or half a dozen of the other, which one you want to deal with. Okay. Back to standard deviation. So we found that the standard deviation for this set of data is 95. What do you do with that? Well, this is just another one of those statistics that you can report on that allows people to understand the shape and the characteristics of your data. You also can describe your data in different ways using standard deviation. So you may have heard people say, you know, within plus or minus 1 standard deviation of the mean or of the average. And that's another way of describing how your data tend to fall together. So in a normal distribution like this one of our building age, the mean plus or minus 1 standard deviation should encompass about 2/3 of your data. When you get out to 2 standard deviations, that's about 90% of your data. You can start to understand where values fall within there. That's really all you need to know about the standard deviation right now. It's another way of describing the distribution of your data. It tells you a bit about the variation. It helps you understand sort of how reliable your data are and are they really fitting well within that normal distribution. So we want to get around now to how can we use some of these descriptive statistics to start building our mental model. And the mental model here is around the hypothesis relating to what data do we have that can help us predict whether a house might have a smoke alarm installed or not. And we have some indicators here that maybe that age of the building might be related to these properties that don't have a smoke alarm installed. So we have sort of a hypothesis there that we'd thought about way earlier when we thought about what characteristics of houses might help you predict whether a smoke alarm is installed or not. So I want to walk through one more really quick Excel calculation we can do that starts nudging us in that direction of making some predictive analyses for this problem. And what I'm going to do to make all of that a little bit easier is I'm going to move a bunch of this stuff out of the way. And so I'm actually going to insert some columns just to move everything out of the way for us. And I'm going to do that repeatedly here just a little bit. And you're going to watch everything sort of shift over there. And I want to just get that out of the way. We're going to focus now on this question of what kind of hypotheses can we start to build based on these data. So we know what an average is now, right? We know that we can use the average age of the building as the central tendency for those data. And we know that that gives us like a representative value for those data, right? So what's the average age of a building that has a smoke alarm installed? And what's the average age of a building that doesn't? Okay, and I'm going to make this formatting go away so that we can start working on this. Okay, so we're going to do average age if false, all right? And what we're doing now is we're starting to work our way into using logic and data together to start to form some opinions about this problem. Now, there's a really great formula in Excel, surprise, surprise, that allows you to do this. So we want to collect the average of these fields right here for which the data are false. Now, I could go through and do this again just by hand, but if you have a really big data set, that's super cumbersome and really not tenable. So what we're going to do is put in a formula here that will allow us to average values in this column based on values in this column. And not surprisingly, this one is also called average if. So like a lot of the other functions, there's your basic ones, and then there's permutations of that you can do for these kinds of operations. So the syntax for this average if function is a range, a criteria, and an average range. Now granted, even it took me a little while to figure out which was which, and sometimes you can go and read up on this, or you can click through and it will give you a little more information about what that means. You can go research in the help menu and whatnot. For this one, what I finally figured out was you want to average from this range, and the criteria for that range is related to the first field. The range and the criteria is this first field here. So our range that we are establishing the criteria for is the smoke alarm, true or false range. The criteria is, in this case, we're going to average the age of the building if it's false. So that, and then the average range means the range for which we are going to actually calculate the average given those criteria. And that is this age of the building. And when I hit return on that, it returns this value here. And here's our friendly little error message again, which I'm going to tell to go away. So I'm going to just do this in months, really clean this up just to go like this. We need to repeat that for when there is a smoke alarm present. And so I'm going to write in this column here, if true, and we're going to repeat that. So we're going to do the average if, which we're a little more familiar with now. This is exactly the same. We know this is our criteria range. In this case, the criteria is true, and our average range is exactly the same again, the age of our building. And now things are definitely getting more interesting. The average age of a building that has a smoke installation, a smoke detector installed, is 212 months. And the average age of a building, if there isn't one present, is 410 months. So it's twice as old. You're more like, so you can't say more likely or not yet, right? I almost even said it myself there. The data are pushing me in a direction now. This is refining my hypothesis. I'm having this aha moment now of thinking, wow, it seems like the age of the building really might be a factor we can use in a model that will predict whether a smoke alarm is present or not. And we can't say that quantitatively. We certainly can't say that in any really statistically reliable way yet. But you have just had a great moment here of walking all the way through from the raw data through your descriptive statistics to an intuition now about the direction you can go in with your analysis. And that's a super exciting place to be. So the next step is to take all of this information back to your team and present what you found and see where everyone else is and how that's going to inform the analysis that you're going to do next.